Okay, so last time we have discussed the classification problem. So as far as the supervised machine learning is concerned, its major application is regression problem statements and the classification problem statements. So two different problems can be solved by supervised machine learning. So under regression category, we have discussed so many regression algorithms like linear regression, simple linear regression, multiple linear regression, polynomial regression, even the logistic regression. This time we have already discussed regarding the classification also. What is classification? How the classification algorithm will work. Under that, we have seen logistic regression, K-NN classifier, and support vector machines in the last session. So this time we are going to discuss this important classifier. This is naive Bayes classifier. Basically, this classifier works on the probability theory, and it is actually based on Bayes theorem in mathematics. So probably you must have studied in maths Bayes theorem or probability theorem, or you must have studied probability in mathematics, and under that you must have studied this Bayes theorem. So basically, this kind of classifier is mostly suitable for the text classification problems, as it includes high dimensional training data set, and it depends on the probability. So it's all about calculation of probabilities of different events, and there is some formula. Based on that, we will able to solve the classification problem statement. So few popular examples can be spam filtration, or the sentiment analysis from the text, or the classification of articles. So mostly, as I said, text classification can be done using naive Bayes classifier, and in future, in NLP, in natural language processing, we will be classifying some text, and based on that, so for that purpose we are going to use naive Bayes classifier in future as well. So the moral of the story, it's some sort of classifier which is dependent on the probability theory, and particularly speaking Bayes theorem. It's already depends on Bayes theorem. So we'll understand what is Bayes theorem and how it is calculated, how to calculate the probabilities. So theoretical part we will discuss first, and after that we will discuss the Python implementation for the same. As far as the naive Bayes classifier is concerned, now there are two important terms. The first one is naive, and the second one is Bayes. Now, Bayes is very clear, as it is dependent on the Bayes principle or the Bayes theorem in mathematics, so that's okay. And it's all about the calculation of probabilities and some equation in terms of some probabilities. As far as the naive is concerned, its name is given naive Bayes because it assumes the occurrence of certain feature, and which should be independent of occurrence of any other feature. So every feature is independent in nature. It's not dependent on anybody else or any other feature. For example, if the fruit is to be identified, then that fruit can be identified based on its color, based on its shape, based on its taste. So every feature has its own contribution, or every attribute, this shape, taste, color, is having its own contribution in order to identify or in order to categorize, classify certain fruit. So that's how it is the name naive Bayes for this classifier. And what is Bayes theorem? So this is very popular theorem in mathematics called Bayes rule, or sometimes even called as Bayes theorem or Bayes law. So now it's all about determination of the probabilities of certain event or the hypothesis based on some knowledge or some prior knowledge. Okay, so here the Bayes theorem is written like this: the probability of A given B equals to the probability of B given A into the probability of A divided by probability of B. Now, what is this? Now, there are some terms like posterior probability or likelihood probability, prior probability, or marginal probability. So, I'll explain this thing in a simple language. So, here, probability of A by B, that means probability of event A when B is true. Okay, event B is true. So, this is probability of A by B is nothing but probability of A when event B is true. Similarly, probability of B by A, that means the probability of B when A is given, that means the probability of B event when A is true. and this is the individual probability A of event A occurring that event, and the probability of B, that means the probability of that B event will occur. Okay, the probability that the B event will occur, that is probability of B, and the probability of occurrence of event A, that is probability of A, and probability of occurrence of B when the A event is true, that means probability of B by A, and probability A by B means probability of occurrence of event A when event B is true or it has occurred, so that is probability of A by B. So if we consider two different events A and B, so its probabilities of, for example, if I have to calculate probability of A, if the event B is true, then this is the formula for that, and these are different terms that are used to calculate the probability of A. Now, in most of the times in machine learning, we need to do such kind of thing. If, for example, I have to do something when some condition is true, so what is the probability for that? Based on that, this kind of theorem can be applied, and we can solve some machine learning problems, or we will be able to solve some classification problem statement. Now, let's assume how it's going to work. Now, as per the mathematically or the as per the solving some numericals are concerned, it's all about to creating some frequency tables to calculate the individual probabilities and the calculation of the probabilities of certain events if certain other event is given. Now, for that purpose, suppose we are having a data set of weather conditions, and the target is whether we are going to play cricket or not in that particular weather condition. So we are having two columns basically. So let's say we will see the data set first. So now this is outlook or the weather conditions, and based on that whether we will play cricket or not, so it's the target. So there are two variables here. One is a dependent variable or the target variable, which is play variable, and another is outlook or the weather, which is the independent variable or the predictor variable or the feature or the input variable or the attribute. Okay, now here we are having 14 number of observations. Now this is 0 to 13, so total 14 number of observation. If weather is rainy, then we will play. If the weather is sunny, again we can play. If the this is overcast, then we can play. So these are some conditions provided over here, and in some cases where if the weather is rainy, then we will not play like that. So there is some random, so I have created some random data over here, so that this is the weather conditions and corresponding targets are given in another column. So our objective is to calculate, to find if the weather is sunny, whether we are going to play cricket or not. That's what we need to calculate. So now our objective is, or the problem statement is, if what to do if the weather is sunny, whether we will go to play cricket or we will not going to play cricket. That's what we need to calculate, and this is some sort of classification problem, because if you see in the first column we are having different observations, and in the second column in the play variable we are having only two possibilities. One is S and the other one is no. So sometimes we may play cricket or sometimes we will not play cricket depending upon the weather condition. So it is some sort of classification problem. Definitely it is not the regression problem. Now it's classification problem. And now if I have to apply this naive based classifier on this, then I will have to calculate the probability of everything. So first of all, I will calculate the individual probability of S, occurrence of S, then individual probability of occurrence of no, individual probability of rainy, or the weather is to be rainy, sunny, overcast. So individual probabilities I will calculate for each and everything in my data set, and that will be marked as the probability of S, probability of no, probability of rainy, probability of sunny, probability of overcast. And final objective that we need to calculate that if the weather is sunny, we have to know whether we will play or not. So first of all, we will calculate the probability of S if the weather is sunny, that is true, and again we will calculate the probability of no if the weather is sunny. Okay, so we will calculate, first of all we will calculate the probability of S or to play when weather is sunny. So if the sunny weather is there, what is the probability that you will play cricket? That first of all we will calculate. Secondly, we will calculate probability of no, that means not to play when the weather, provided that the weather is sunny. So both the probabilities we will calculate, and then we will compare which is higher. If the s wali probability is higher, then we will say that we can play cricket if the weather is sunny. And if no wali probability is higher, then we will say that we can't play cricket if weather is sunny. That's what we have to do, and that's the objective for this. So let's make a frequency table for this. Now here, this kind of table can be made from the previous observation that whatever we have in the database. Now here we are having the weather, and this is S and no. So if the weather is overcast, in that particular case, 5 times we can play the cricket, and 0 times we will not play cricket in this particular weather. If the rainy weather is there, there are two observations which says that you can play cricket, and there are two observations which says that you can't play cricket. And if the weather is sunny, in that case, three observations suggest that you can play cricket, and two observations suggest that you will not play cricket. So total number of S are 10, and total number of no are not 5. I think it's 2 plus 2 4. It should be 4. There is some mistake, typing error here. So there should be 4 instead of this 5. Okay, so no has occurred 4 times in this particular data set, and S has occurred 10 times. So total 10 plus 4, 14. Okay, so this is the frequency of no and the frequency of S. Similarly, if you can compare these things, or this overcast and all those things, for overcast, the S is for 5 times and no is for 0 time, and so is the case for other seasons, okay, or other weathers. Now we need to calculate the probability, individual probabilities, we can say. Now, as far as this is concerned, as far as this overcast is concerned, now we can calculate its probability of overcast. So overcast has occurred for 5 times. Okay, so in our data set, the overcast has occurred 5 times. Now 5 divided by 14, that is 0.35. Okay, so 0.35, that's the probability of overcast. Now as far as the rainy is concerned, rainy has occurred 4 times in our data set. Out of 14, 4 times there is raining, so its probability is 0.29. The probability of rainy is 0.29. Now, as far as the sunny is concerned, sunny has occurred 5 times, 3 plus 2. So its probability is 0.35 again. Now, probability of no is 4 times in total 14 observations. So its probability is 0.29. And S has occurred 10 times in our data set, so its probability is 0.71. Okay, so this is how we have calculated individual probabilities: the probability of overcast, probability of rainy, probability of having sunny, probability of S, and probability of no. So simply looking at this particular data set, total 14 number of observations are there. Out of that, 10 are S, so 10 divided by 14, that becomes the probability of S. Okay, and no is for 4 times only, so 4 divided by 14, so that's the probability of no. Similarly, we will count the rainy. So rainy is 1 2 3 4 times there is rainy, so 4 divided by 14, that is the probability of rainy, and that will be repeated for others as well. So for overcast and sunny, that same thing will be followed to calculate the individual probabilities, and this is how we will calculate the individual probabilities. Now we will calculate probability of S when sunny weather has occurred. That's the number one probability we'll calculate. And we will calculate probability of no, not playing, when sunny weather has occurred. And we will compare both the probabilities, and based on that, if the probability of S, that means to play, is higher than probability of no, then we will say in case of sunny weather you can play the cricket, or the output is play, or the S, you can play. And if the probability of no is higher, then in that case we will say you can't play cricket in case of sunny weather. So now applying the Bayes theorem here, so we have to calculate, first of all we'll calculate this term, probability of S, the first one, the probability of S when sunny weather is there. So that is nothing but the probability of Sunny when S is there, and probability of into probability of S divided by probability of Sunny. Okay, so this entire numerator term divided by this Sunny. Now, as far as the probability of Sunny is concerned, we know the probability of Sunny is around 5 divided by 14, which is 0.35. Okay, that we already knowing. Probability of S also we know the probability of S is around this 10 divided by 14, that is 0.71. So these two things are we are knowing these two things, two important things we are knowing, because they that can be directly calculated. So probability of S and probability of Sunny, that is probability of Sunny is 0.35 and probability of S is 0.71. So that two terms are very much clear to us. Now important thing is that probability of Sunny when there is S. Okay, for S, now this we have to calculate. Now this is very important probability, and this we must calculate. And once you calculate this probability, then we can put all the values in this formula, and then we can calculate this probability. Now as far as S is concerned, S is for 10 times. So S is for 10 times. This S is total occurrence of S is 10 times. Out of this 10, 3 times there is Sunny. Okay, 2 times there is rainy, and 5 times there is overcast. So out of 10 occurrence of S, there is 3 times sunny weather, 2 times rainy, and 2 times overcast. So we can consider probability of this thing, the sunny when this S is given, is 3 upon 10. So it will be 3 upon 10, so that will be 0.3. Now we got all the probabilities from the right hand side equation, so we can put that. So 0.3 into 0.71 divided by 0.35, so it comes around 0.60. Okay, so we will get, so probability of play cricket when there is sunny weather is equal to 0.60. Okay, so it will be 0.60 is the probability to play cricket when there is sunny weather. So that's what we calculate from this equation. Now, this is one probability we got, that to whether to play or not to play. Now, the second one important thing, probability of no when there is sunny weather. Okay, probability of no when there is sunny weather. Now, here what we'll do, we will calculate probability of sunny whenever there is no occurred, and probability of no and probability of sunny. So probability of no is straightforward, that is this much, 4 divided by 14, it is 0.29. And probability of sunny, that is again straightforward, it is 5 divided by 14, 0.35. Now we have to calculate probability of this sunny when there is no has occurred. So total number of observations are 4, so out of that, 2 are sunny. So 2 divided by 4, that we will get as a probability for that particular event. So 2 divided by 4 is 0.5 for probability of sunny when there were no has occurred. So 0.5 into this 0.29 divided by 0.35. So it comes around 0.41 by putting everything in this particular equation. So we put all this stuff in this particular equation. So its probability will be like this one. So its probability will be 0.31, sorry, 41. And now you can compare, the probability of playing cricket is higher than probability of not to play cricket. So that means whenever there is a sunny weather, you can definitely play that game or that cricket. So hence on sunny day, player can play the game. So this is the basic funda which is used in naive Bayes classifier. So every time you apply the naive Bayes classifier, it is at the back end side, it is going to calculate all the probabilities, and based on those probabilities, it is going to predict whether to play cricket or that game, or whatever problem statement can be. It can be a text classification, article classification, fruit detection, or any disease detection, maybe chronic kidney disease detection, brain tumor detection, whatever. So it is going to calculate the probabilities for all the stuff, and after that, finally it will predict, or it is going to classify a particular thing. Now we'll discuss the Python implementation for the same thing. Now, as far as the Python implementation is concerned, we are going to use the same data set as that of previous one. So this is the data set of some social media or social networking site advertisement, where we have collected the IDs of user, their gender, their age, and their estimated salary, and whether they have purchased the particular item or not. And based on this thing, we are going to process this data, and after processing this data, we are going to calculate whether this particular person has purchased that car or not, based on some inputs. Now inputs could be the salary and the age of that particular person. So previously we have done same thing using knn classifier. This was the code for the knn classifier, and also we have repeated the procedure or same thing for the svm classifier. And this time we are going to create a new python file, and this file, in this particular case, in the new python file, we'll be doing the naive bayes classification. I'll create the file by this name, naive bayes classifier.py, and here is the file. So let me zoom. Okay, so now as usual we are going to follow the similar steps that we used to follow in the previous practicals. Now the step first is to load the important python libraries. Now here this is step number 1, loading the required packages. Now here the first one is import numpy as np, then import pandas as pd, and then import matplotlib.pyplot submodule as plt. Okay, now that's all about. We have loaded the important libraries. Now step number 2 is importing the data set. Okay, so importing the data set. So this is loading the data set. All these steps are going to be same for all the practicals, and I'll be creating some variable called data underscore set equals to pd dot read underscore csv function, and here I need to mention the name of that csv file. So it is social underscore network underscore ads dot csv. Okay, that's the name, and then we can actually print some part of our dataset. So dataset dot head function, that is going to print the first 5 rows from our dataset, and that will check it out whether everything is okay. Okay, so now everything is fine, that we have printed these first 5 rows, and its user ID, gender, age, and estimated salary, and purchased. These are some variables available with us. Now the next important step is to extract dependent and independent variable. Now in order to extract the dependent and independent variables, definitely we are going to slice our data set, and for that purpose we are going to follow the step number 3. So this was our step number 2, and this will be now step number 3. And in this step we are going to extract the predictors and the target variables. So as far as the predictors are concerned, which are input variables, and as far as the target is concerned, that is nothing but the output variable. So that's what we are going to extract from here, and again I will be following very simple technique. So here x equal to, which is the input variable, we can say, so data underscore set dot I location, and then I should provide the indexing, so all rows and the column number 2 and 3. Okay, so this is column number 0, this is column number 1, this is column number 2, and this is column number 3. So that's how 2 and 3. And as far as the y is concerned, We need column number 4. So dot, and this will be okay, column number 4 this time. And of course we need to consider only values from this data frame. So dot values. Okay, so this is how I will be extracting the dependent and independent variables. And as I have extracted all this stuff, the next important step will be splitting the data set into training and test data set, sub data set. So that will be our step number 4 as usual. So step number 4, splitting the data set. So we will split it into training and test. So for that, I'll be creating one variable called x underscore train, then x underscore test, then y underscore train, and of course the y underscore test as usual. So y underscore test. And for that purpose, train test split function we generally use. So for that, we need to import from sklearn dot model selection library, import train test split function, and directly we'll call that function over here. And from x we will split it into x train and x test, and then y will be split into y train and y test, and then test size we have to provide over here, and that will be 0.2. It can be 0.25 also, or as per your choice, and random state equal to 0. Okay, so now this is how we have splitted our data set, and now we will get 4 different variables: x train, x test, y train, and y test. If you want to print all these variables, you can definitely print here, or you just write print statement and you will be getting the data in x train, x test, y train, and y test, and you will be displaying that data also. But for now it's not actually needed, so we'll directly go towards the next step, step number 5, and the that step is feature scaling. Okay, so step number 5, feature scaling. And now what is feature are nothing but input variables or the predicted variables. Now these are x train and x test, so these are the input variables that must be scaled. And in order to scale that, as usual we'll be using from sklearn dot pre-processing library, import standard scalar. Now this scalar will import over here, and we'll create an object for that, and here the standard scalar object. And now with this we will scale our features. So first of all, x train equals to this sc dot fit transform function, and we need to provide here x underscore train. Then x underscore test equals to same procedure, sc dot fit transform over here, and then here you need to specify x underscore test. Okay, so that's it. So we have scaled our features, and after scaling, if you want to print your features before scaling and after scaling, you can definitely print it out, and you may see the different things all about your features. Now this was step number 5, that scaling the features. And now the next important step is fitting the naive Bayes classifier. Now in order to fit that classifier, so this is step number 6, fitting or training the model. So you're fitting the naive Bayes classifier. And here is actually change as per as the previous practicals are concerned, and whatever coding we have done in the previous cases. So there is just a little change here. So you will see here in this particular line, or only 2 lines are going to change in our entire file. Rest of the contents are going to be same. So here what we are going to do, so your classifier we can define, but in order to define the classifier we should load some library over here, and from that library we should import this classifier. Okay, so now for that purpose we can use the sklearn library again. So sklearn dot navebase import. Okay, so that's in the navebase library. So that's how we are importing from that particular library. So here we'll import the Gaussian navebase. Okay, so now we can actually use this Gaussian naive Bayes and we can actually uh, uh, find out the model for that. That will be classifier, and then we'll train our model on X train and Y train data. So here we'll call this simple thing, and here once the model is initialized or it is object is created for that or the classifier is defined, now it's time to fit the classifier and using X underscore train comma Y underscore train. So if you clearly notice in this particular thing, only these two lines are different than the previous one. So if you want to compare different algorithms for their accuracies, so it will be in a single code only. So you can just extract after this, and after that we can apply 4 to 5 different algorithms, and you can extract the accuracies for different algorithms, and at the end we can comment on it which algorithm is better or which is producing the best results as far as this accuracy is concerned. Now, okay, so now as we have trained our model here, so here we can check out the performance of our model also. And in order to find out the performance, so that will be step number 7 for our case, the performance. And we know as far as the performance is concerned, the confusion matrix and the accuracy can be calculated. So in the last session, I have asked you to calculate the accuracy based on the confusion matrix which we have provided to you, and based on that confusion matrix you will have to extract the some true positives, true negatives, and other stuff, and based on that you should calculate the accuracy of your model. Okay, so that was the assignment. Hope you have already completed that assignment, and otherwise we'll discuss some part of it in this particular lecture. So step number 7 is the performance, and the performance can be calculated based on two things. One is confusion matrix and the other one is accuracy. So in order to calculate the performance, so from sklearn library we should import something. So from matrix import confusion matrix. So this confusion matrix will be used to calculate the accuracy. And for this confusion matrix, there are two important arguments. The first one is the actual values, and the another one is predicted values. So now, in order to get the predicted values, I should create a variable called y prediction. So once I create this variable y prediction, so I should use your classifier dot predict function, and then I should give some known data. So which is x test. So this time I'm giving unknown data test. And based on this, whatever will be the prediction that I will be getting in y prediction variable. And once I will get that thing, now I can calculate confusion matrix cm equals to confusion matrix underscore matrix. And here you will have to pass y underscore test, which is the actual data, actual values, real values, and y underscore prediction. These are the predicted values. So here y underscore test is the actual values that are in the database, and the corresponding prediction is y prediction. So if I give x test from the data set, so in front of x test, in the target column you will see y test data. And if you give that to the classifier will predict some different result called y prediction. And now I will compare that thing y test and y prediction, and based on that I will calculate how many true positives I'm having, how many true negatives I'm having, how many false positives I'm having, and how many false negatives I'm having. And based on that I'll be able to print the confusion matrix. So let's print here the confusion matrix, and let's see what happens to this. Okay, so this is data set, and now the confusion matrix is live here. So 54 number of things are true positive, 21 are true negatives, 4 are false positive, and there is one observation which is false negative. So from this, actually, you will be able to calculate the confusion matrix. And now the accuracy formula is the true positives plus true negatives divided by total population. Now the total population is the summation of 54 plus 4 plus 1 plus 21, and the true positives are 54, and the true negatives are 21, and this is 4s are for false positive, and 1 is there which is false negatives there. Now we can calculate these terms from this matrix. Now as far as, if you see, this is not a list. This is actually, if it was list, it should have commas inside it. Okay, now this is not having the commas, that means it is not the list. So that's the difference between list and np array or numpy array. In case of list, you will find that there are commas in printing, but in case of numpy arrays in Python, you will not find any comma. Instead, you will find some space in between the two values. So this is numpy array. Now, in order to calculate the total population, so it can be simply np dot sum. So let's do that and let's find out the population. So the population, or the total, or otherwise I'll use a total variable. So total equals to this np dot sum, and then you just give this cm. So you'll be getting the total of all these values. And if you want to print it, if you can actually try the printing also, print total. So you will get the summation of all those terms. And here we go. So we are getting 80 as the sum of all these things, 54 plus 4 plus 1 plus 21. So likewise we are getting 80 as the total summation for this. Okay, now as we know, this is the total population of it. Now we need to calculate the true positives and true negatives. Now this, and which will be divided by this factor, total factor. So in order to calculate true positive, TP, now we need to do slicing over here. We need to extract something. So cm of, this is the zeroth array. Now we need to first of all provide the array number. So this is zeroth array, and this is first array, because they're two-dimensional array. So having two arrays inside it, inside this one two-dimensional array. So first of all, this is zeroth array, and this is first array, array at the first location. Now, so zeroth array and zeroth element. Now this is array number and this is element number. Now zeroth array, that means this 54 or this first array, and out of that first element, that is 54, that will be a true positive. And if you want, you can print it out also, this TP value. And then we will calculate this true negative TN value, which in this particular case, now just quickly answer in the chat section, what should I write for the true negative. Okay, so as comparing this previous one, true positive, I have written 0 comma 0 cm. Okay, 2 1. Okay, now this is 0, first one is 0 and second one is 1. So this is zeroth array and this is array number 1. So there is no second array. Okay, so index will always start from 0, considering that. Okay, 21 will be there, definitely there, but what should I write in cm bracket? Cm and square bracket, what should I write? Now in case of first thing, you see this is two-dimensional array. Okay, so now there are two square brackets, and in outer square bracket there are, this is one square bracket wala array and this is another square bracket wala array. तो ये टू डायमेंशनल array किस तरह से पता चलेगा, क्योंकि इसको दो ब्रैकेट्स हैं, दो स्क्वायर ब्रैकेट्स, तो टू डायमेंशनल array हुआ. तो ये जो आउटर ब्रैकेट है, इसके अंदर दो एरेज है. दिस इज वन एरे having one square bracket single dimensional array, and this is another single dimensional array. तो इस array का इंडेक्स होगा 0 और इस array का इंडेक्स होगा 1. ओके, राइट. सो इफ आई हैव टू एक्सट्रैक्ट दिस वन, तो मुझे फर्स्ट एरे में से, मतलब जीरोथ एरे में से जीरोथ एलिमेंट चाहिए. तो फ्रॉम द फर्स्ट एरे I need zeroth element, that is 54. Now for the second array, for this array, सो tn is this value 21 value, तो ये सेकंड एरे के अंदर है, मतलब फर्स्ट. Okay, very good, very good. Now you have correct 1 comma 1, so this will be 1 comma 1. So that means first array, इसमें का zeroth element है 1 and the first element is 21, so I need 21, so this will be like this only. And if you want, you can definitely print it out. This will be tn value, and you can definitely check it out all these values. So let's run this thing, and now we have got the population as well as the true positive value as well as the true negative value. Now I can comment out all these values, the print options, because I don't need the printing now. I have tested everything, and now the accuracy can be calculated. So accuracy equals to, we know the formula, TP plus TN and divide by total population, that is this variable. Now this will be the accuracy formula, and that's what we have discussed in the last few practicals, and this is how the accuracy for our model can be calculated. And I suggest, or I will ask you to do this for all the previous practicals or whatever we have done, and based on that you just calculate the accuracy for each and every model over there. And once you get the accuracy from the confusion matrix, after that you may display that accuracy. Okay, so once we are having this accuracy using the true positive and true negative values, now we can print the accuracy. Accuracy equals to, then comma, this accuracy variable. Now here we go, and now we will be able to print the accuracy of our network as well. And now this time we are getting 93.75% accuracy for our network. Okay, now this is actually the testing accuracy I'm talking about. For training there will be a different accuracy. Okay, for training definitely we'll be getting different accuracy value, because I'm using here, for prediction I'm using test data, so it is the accuracy for test data set. If I use your train data set, then that will be the accuracy for training data set, and in that case the confusion matrix will have y train and y prediction. So you can try that also. So as a assignment I am also giving you that task, that you will calculate accuracy values for training data set as well as for the testing data set. So now after that the next steps comes here. Now next steps is, as you know, prediction for the real data. And as far as the prediction for real data is concerned, what you will do, you will be taking user inputs for age and the estimated salary. Then you will scale that using standard scaler, and definitely you will be applying this classifier on it using the predict function, and the predict function will give you some result. And that result, you after that you may apply the if statement over there, and based on that you can predict whether the particular person is going to purchase the car or not going to purchase the car. And now as we are having multiple algorithms like logistic regression, naive bayes, svm, knn classifier, at least four different algorithms we are having. Now you can compare the results of all those algorithms, all those machine learning algorithms, and you can make a table for all those algorithms. So we're going to discuss few more algorithms in the next lecture. So before we conclude with this session, let's quickly revise these steps that we have followed. Now step number one is loading the required packages. Step number two is loading the data set. This is how we can load the dataset, and the extracting the predictors and target variables, and the splitting dataset into train and test sub datasets. Feature scaling is here. And before this, so once before actually splitting the dataset or before you extract the dataset, here can be one additional step. After the second step, after loading the dataset, there can be one additional step like pre-processing the datasets. Now if your dataset is having some anomalies like empty cells and such kind of things, so you can use the pandas library for cleaning purpose. And now four different cleaning techniques or the scenarios where we have seen the cleaning is required. Now number one, where the empty cells are there we need to clean. Duplicate data is there, duplicate entries are there. Now how to find the duplicates? There is simple function or method which will show you how many duplicates are there inside your dataset, so you can actually find out that duplicates and you can drop such duplicates. as far as the empty cells are concerned, either you can drop that or you can calculate the mean, mode, or median, or any value, or you can fill that empty cells using the fill na function. And for that, in order to fill some data, you can calculate the mean of that entire column, that means the average value of that column, or the median of that column, the center value if the column is sorted ascending order, or the mode, that means the most frequent occurring value, instead of that empty cells that you can fill over there. So that's only a possibility for that thing. And sometimes you can check it out for the wrong data in your data set. So for that purpose, again, you can follow some cleaning technique. And if the data is in wrong format, again, you may follow the cleaning techniques. For example, if there is date column, we have used date string function to convert into a normal date string, so that we can fill that empty or that wrong format data. So four different techniques that you can follow to clean the data. So that can be the additional step you will have to do after this step number two, loading the data set. And then before we extract these predictors and target variables, there could be one more step called encoding. So as far as the encoding is concerned, there could be two encodings are available, that is a label encoder and one hot encoding is there. So you can choose from that, and you can encode the categorical variables. Now categorical variables mean like this, male and female. So now you can assign 0 to male and 1 to female. So now right now we are not using this column, that's how we are not doing any kind of encoding. But I'll suggest you, while you are doing this thing, you try to use this column also, so that you will be encoding this column, and after encoding you will be using this column and three columns. You try to do this practically using three columns, and then check it out what is the accuracy by after using three columns, and what accuracy you are getting without considering the gender column. Okay, that's also you can do as an assignment. In all the practicals you do such assignments, in logistic regression, in knn classifier, in naive bayes, and in SVM classifier as well. And again, we are going to discuss decision tree and random forest classifiers in future. For that also you repeat the similar procedure. After that, there will be feature scaling or the normalization of your feature, and for that we are going to use the standard scaler over here, and that will scale your features. And you may go for the PC also if your data set features or number of attributes are large, but this time you are having only two attributes, so not to worry about it. But let's say if you are having more than 20, 30 attributes or more than 10 attributes, you may go for the PCA as well. Okay, so that's again the additional step can be there for this. And after that, fitting the classifier. So whatever may be the classifier, you just have to fit that classifier. And here we are talking about naive Bayes classifier, so we are loading that classifier over here. But you may consider different classifiers as well, like knn, and based on that, only two lines of code. Okay, so sorry, these two lines of code is going to change. Only these two lines will be different, and rest of the things will be same in case of other classifiers as well. So we have used a couple of classifiers over here. So most of the code, or nearly all steps are same, but only two steps are uh, different, which is, or two lines are different, which are this line in the fitting the classifier. And once we fit the classifier, then we can calculate the performance of that classifier as well. And after calculating the performance of that classifier, we can actually calculate the confusion matrix and the accuracy. And the confusion matrix and accuracy, we can print it out. For that purpose, the accuracy formula is given to you, and using some numpy slicing, you will be able to find out the accuracy of it, and you can print it out like this one. Okay, now this is the accuracy measure, and I will suggest you just make the table for different classifiers, their different accuracy values, and based on that you can comment on it which algorithm is more suitable, and which is better, or which is providing the better accuracy for your problem statement. Okay, so that's all, or that's the end for today's session. And now we will wait in the chat section for a few more minutes for your doubts and queries regarding the today's session.